In this example, we're asked to find the domain and sketch a graph of the function. And here we're given the reciprocal function 1 by x. So the first thing that we need to do, find the domain. Now keep in mind here, we are working with the reciprocal function or a rational function. So these types of functions have domain restrictions. We know that a rational function is undefined or does not exist if that denominator is equal to 0. Now we luck out in this case, the only term in the denominator is x. So we can automatically conclude that x cannot be equal to 0. So in other words, x could be any real number our little hearts desire except for 0. So in interval notation, we would say that x is an element of the interval from -infinity to 0. Now notice we use our round parentheses at this value to exclude it. But we also need to go ahead and unite this interval with the other half of the real numbers, 0 to +infinity. So now that we have this set of all possible inputs that are going to produce a real valued output, we're ready to set up our table of values. Now we need to be careful with rational functions. From our interval notation, we can see that x can get infinitely close to 0, but it can never touch 0. So with this in mind, we're going to want to think about values in between the whole numbers when we set up our table of values. So when setting up our table of values and selecting our inputs, notice how we've selected a value or a fractional value in between -1 and 0 so we can better appreciate what's happening with this graph. I want to pause for a cause real quick and think about when we substitute that value, -1/2, into the denominator of our reciprocal function, we have to recall that fractions in the denominator will flip. Or more formally, we multiply by the reciprocal of the denominator. So we can rewrite this as 1 multiplied by -2 divided by 1. And we'll see those 1's cancel each other out, leaving us with -2. Now the same idea is going to hold true here when we substitute +1/2 into our function. So substituting our x values in, we've produced their corresponding outputs. And we can see that when x is -2, y is -1/2. When x is -1, y is -1. Now when x is -1/2, we see that y is -2. So notice here that as these x values are getting closer to our undefined 0, the y values are getting smaller, or approaching -infinity. Moving on to our positives, when x is +1/2, we find that y is 2. When x is +1, y is 1. And last but not least, when x is +2, y is 1/2. So notice in this case, as these x values are approaching 0, notice how these y values are in fact getting larger. So as these fractions get smaller and smaller, their corresponding y's get bigger and bigger. So let's see what this is going to look like on our graph. So we have x is -2, -1/2. We have the ordered pair -1, -1. And then last but not least, we have -1/2, -2. So right about here. So again, notice as these x values are approaching 0, the y values are getting smaller. But they're never going to cross that y-axis because we know from the domain that x cannot be equal to 0. So we can even indicate this on our graph using a little dotted line. And just remind ourselves here that x cannot be equal to 0. The function cannot cross this line. And as our x values are getting smaller and smaller, these are approaching 0, but never crossing our x-axis. And we can see a similar shape taking place over in quadrant 1. We have the ordered pair +1/2, 2, positive 1, 1, and then positive 2, 1/2. So again, as these x values approach 0, they're going to get infinitely close, but they can never ever cross. Same idea is holding true here on our x-axis. These y values are getting closer and closer to 0, but never going to cross. Now looking at this graph, again, we can actually see the range. Just like we have this invisible line where x cannot be equal to 0, the graph can't cross, we have the same idea holding true here at our x-axis. The y values cannot be equal to 0. So we can see that y could be any other positive value, any other negative value, but it can never be 0, which gives us our range. So we know y cannot be equal to 0. So in interval notation, we would say that y is an element of the interval from -infinity to 0, united with the other half of the real numbers, 0 to positive infinity.